All right, so lesson 110, classifying numbers. So if we start off here, last lesson there we were comparing numbers that were written in scientific notation. So if we do this first one here, so the first one, 92, were written as decimal notation. The second one, 9.2 times 10 to the first, is scientific notation. So we need to get it into the same one. Now for this one, I'm going to just convert it into decimal notation. So to get it out of scientific, we're going to move it one time. It's positive, so that makes it number bigger. So we're moving it to the right once, which makes it 92. They're both 92. So in this case, it's going to be equal. So building off of those. So right now we've just been talking about numbers in general, some of the different things we can do about it. Now here we're going to go through and we're going to start breaking them up into different groups and classifying. So in other words, naming what type of numbers they are. So what we're going to deal with is the real numbers, which is the numbers that you're going to use in everyday life. So starting with your natural numbers are your counting numbers. So think when you count objects, you start counting 1, 2, 3, 4, and continuing on. So they're going to be whole numbers, so no decimals, no fractions, and they're all going to be positive. Whole numbers are going to be those counting numbers, but we're also going to include 0 into this. Next, we have the integers, which will be those whole numbers plus all of the negative counting numbers. So like 1, 2, 3, 4, 5, if we go make those negatives. So think the whole numbers, so anything from negative 1, 2, 3, 4, including 0, and negative 1, negative 2, negative 3, all of those will be included in your integers. So again, integers still do not have fractions or decimals. But what does are rational numbers. So rational numbers are any number that can be made into a fraction. So this is going to include everything that's above it. So all of those integers, all those positive numbers, the negative numbers, all of them are going to be rational numbers because those whole numbers, we can always write as, say, like 6, for example. We can write it as 6 over 1. Or if we had negative 42, we could write it as negative 42 over 1, which makes it into a fraction. So we can always make those into rational numbers. Now, any repeating decimal, so like 0.3 repeating, so 3, 3, 3, 3, 3, and continuing on, we could always write it as a fraction, so 1/3 in that case. Or terminating decimals, like 4.25, we could write as 4 and 1/4. We could write that as a fraction, so those would all be rational numbers. Anything that we cannot make a rational number would be an irrational number. So irrational numbers would be like the square root of 2, or pi is another one, or the square root of 97. What wouldn't be would be like the square root of 81, which could be 9, or like the square root of 25, which could be 5. Anything that when you take the square root of that would make a nice whole number, those are going to be rational numbers. But anything that would be a non-terminating, non-repeating decimal, so the decimal does not ever end, it keeps going on forever, and it never repeats, are going to be irrational numbers. So you're going to get questions like this. Which of the following are integers? Well, the first one's got a fraction. An integer cannot be a fraction, so that one is out. 1 is an integer. So whole number, no fraction, no decimal. Integers can also be negative, so negative 1 would work. Integers also include 0. So those would all be examples of integers. So which of the following would be a rational number? So a rational number is what numbers can we write as a fraction? Well, square root of 10 is not going to be real pretty. If I grab a calculator here. So second square root of 10. So if we do the square root of 10, we get 3.16227766, and that's going to keep going on. So that one does not terminate, does not end, it does not repeat at any time. So this one will be irrational, so it's out. If it's going to be an irrational number, it does not fit as a rational. Pi, automatically irrational, so this one will not work either. 77.68, and it's got the bar above it. That bar above it means it's going to repeat. So this would be 77.686868686868, and continuing on forever like that. If it repeats, it is a rational number. And the square root of 81 is actually going to be 9, so that makes it a rational number. Okay? You're also going to get problems like this one here. So which of the following would describe 66.2 repeating? So out of these, so if we look at natural numbers cannot have a decimal. So natural number would be out. Same thing, whole number cannot have a decimal. Rational number can have a decimal, but it has to either repeat or terminate. Ours repeats, so it fits as a rational number. And then integers again are whole numbers. They don't have a decimal, they don't have a fraction, so that one's out. The only one that will work is a rational number. Now, which of the following would describe 46? Well, same thing here. So integer doesn't have a decimal, doesn't have a fraction, can be positive, can be negative. That fits. If it's an integer, it will also be a whole number. Actually, I should say the other way. If it's a whole number, it would be an integer. But a whole number is going to be any of your counting numbers, so no decimal, no fraction, and it's positive. 46 is that, so it fits a whole number. Now, these other two, irrational number and rational number, they will never be both. It's either going to be one or the other. It will never be both. So 46, could we write it as a fraction? Well, yeah, we could. We could write it as 46 over 1. So that makes it a rational number and not an irrational number. So it's only one or the other. It can't be both. Either it's rational or it's irrational. And that's the lesson. Let me know if you have any questions. Otherwise, we'll talk to you later.